Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So we are discussing about solid mechanics and materials. So in this subject, already we have discussed about various types of stresses and how to calculate the shear force and bending moment values, and then how to draw the shear force and bending moment diagrams we have discussed. And also we have discussed in previous session how to calculate the slope and deflection of various beams. So in this there are two methods. One is Macaulay's method, another one is Maxwell's theorem. So according to these two methods, how to calculate the slope and deflection we are discussing. So in this session, today's session, I want to discuss about by using Macaulay's method. So how to calculate the slope and deflection of a various beams. So already theory part is we have completed, but in this session, in today's module, we will see how to solve the problem. Whenever the problem given on particular beam, it may be simply supported beam or it may be cantilever beam. By using Macaulay's method, how to calculate the slope and deflection. So already we have derived some equations and already used for slope and deflection calculation. But particular in this method, we will see in this session. So before going to enter the main topic, we should know the course outcome. The student should be able to demonstrate the slope and deflection of various beams by using Macaulay's method. So they can demonstrate the slope and deflection of various beams by using normal methods and by using empirical relations, but particularly they have to use this Macaulay's. What is this method? So already we have discussed in theory part. So those whatever you studied or learned, those equations apply for these problems. See, in this Macaulay's method for slope and deflection, the main topic. See, the problem, given problem is a horizontal steel girder having uniform cross section. The girder given uniform cross section is 14 meters long and is simply supported at its ends. The type of beam is here simply supported beam. So it carries two concentrated loads as shown in figure. So already shown in this beam is a simply supported beam. So already we know about simply supported beam and cantilever beam and overhang beam. Already we have discussed in theory part various types of beams. So here you can see these two supports are simply two supports are there. These supports reaction supports. One is RA reaction and RB. Clear? And two point loads, concentrated point loads is given with a certain distance, that is 3 meters from the left hand and 4.5 meters from the right hand. So the remaining, the middle portion is 6.5. So for this diagram, calculate the slope and deflection by using this Macaulay's method. So the given the span L is 14 meters. L. Clear? So the given length 14 meters convert into mm. So 14 into 10 cube and load at C, that is W1, 12 kilonewtons. 12 into 10 cube newtons. Load at D, that is W2, 8 kilonewtons, 8 into 10 cube. So the modulus of velocity is 200 gigapascal. So convert into Newton per mm square. So giga 10 to the power of 9, and then again convert into mm square, Newton per mm, divided into 10 to the power of 6, 200, multiply with 10 to the power of 9, Newton per meter square, and again convert into mm, so Newton per mm square. So you will get 200 into 10 cube Newton per mm square. And the moment of inertia, that is 160 into 10 to the power of 6 mm to the power of 4. So that the given values convert into the single unit. So the mm, it may be in mm or meters, but all should be in same unit. See, here the reaction forces are there, RA and RB. So first of all, you should calculate the reaction forces RA and RB. So RA plus RB, 12 plus 8, total 20. But individual forces, what is RA and what is RB, you should calculate. So by taking moments, here calculated the moments, here taking moments about A, 12 into 3 RA plus 8 into, so remaining this 6 plus 6.5 plus 3, 9.5. So here see RB into 14. So RB into entire length, that is force multiply with length, is equal to 12 into 3 plus 8 into 9.5. So you will get 1 1. So here RB calculate. So RB will get 8 kilonewtons. So you know RA plus RB upward forces are equal to downward vertical forces. RA plus RB is equal to 20 kilonewtons. See, in this, RB already you know calculated 8 into 10 cube newtons, and RB 20 minus 8, so you will get 12 kilonewtons. So now taking A as the origin and using Macaulay's method, the bending moment at any section at a distance x from A. So here, by using Macaulay's method, the bending moment at any section capital X at a distance A. Distance A. Here take any section, and then you can take a section and then find out bending moment. So you know the bending moment, the deflection equation, by according to the bending moment, the bending stress equation already we have learned in theory part. So EI into D square d square y by dx square is equal to minus 12 into 10 cube into x plus 12 into 10 cube into 3 into 10 cube. So what is this 12 into 10 cube? See here 12 kilonewtons, 12 here load, take any section between in this A and C, 12 kilonewtons, multiply with x, and then again x minus 3 and plus 8 kilonewtons. So 12 kilonewtons RA, RB and RA values calculated. So here substitute in this equation. Now integrate the above equation. This is the basic equation. So integrate. Whenever integrate the above equation, you can see the EI into dy by dx. So d square by y by dx square changed into EI into dy by dx. That is minus 12 into 10 cube into x square by 2. Here 12 into 10 cube into x square by 2 plus C1. That is a constant C1. You should calculate the C1 value by using boundary conditions. And similarly, 12 into 10 cube into x minus 3 into 10 cube whole square by 2. So integrate this portion. Plus 8 into 10 cube into x minus 9.5 into 10 cube whole square by 2. So integrate the above equation. So after simplification, you can see the final value 6 into 10 cube into x square plus C1. Similarly, 6 into 10 cube into x minus 3 into 10 cube into whole square plus 4 into 10 cube into x minus 9.5 into 10 cube. So this is the first equation. Similarly, the second equation. So 2 into 10 cube into x cube by 3. Again integrate. So double integration. Integrate the above equation. So again we will get the value C1x plus C2. C1x plus C2. Similarly, the second term 2 into 10 cube into x minus 3 into 10 cube whole cube plus 4 into 10 cube. So integrate this term. So 4 into 10 cube into x minus this x square by 2 here. So similarly here also. So the x minus 9.5 10 cube actually square. This one this term we will get in terms of cube, and actually this one is a square 2. So we will get here cube the integral x square x cube by 3. So similarly here simplify the above equation. EIY into 2 into 10 cube into x cube plus C1 and C2. So we calculate the C1 and the C2 values by using boundary conditions. Need to calculate and then substitute in this equation. So now for deflection under the 12 kilonewtons, substituting x is equal to 3 meters or 3 into 10 cube mm in equation 3 up to the first dotted line. In equation 3 up to the first dotted line, this one. So you will get deflection under the load 12 kilonewtons. EA YC is equal to up to dotted line 2 into 10 cube into x cube plus the 193.2, that is C1, and the remaining value substitute here, and you will get finally in terms of EA the deflection at under load C, that is 12 kilonewtons. So now you know the E and I values given in problem. 2 into 10 cube Newton per mm square. And I also given 160 into 10 cube, 10 to the power of 6. Now calculate this one and simplify. You will get 16.4 mm. So this is the deflection at C point. Similarly, calculate deflection at D point. Deflection at D. So D means here load is 8 kilonewton. So again substitute here EI and then you will get 20.9 mm. So that is a deflection at point D. So like this, need to calculate by using Macaulay's method. So deflection and slope of a given beam. A problem 2, you'll see in this, in first problem only I asked deflection, but in this need to calculate slope. A horizontal beam AB is freely supported at A and B, 8 meters apart, and carries a uniformly distributed load. So the UDL, so not point load, the uniform distributed load of 15 kilonewton meter. So including its own weight. A clockwise movement of 160 kilonewton meter is applied to the beam at a point C. So clockwise movement. So 3 meters from the left hand support A. Calculate the slope and deflection at C. If EI is structural rigidity is given 40 into 10 cubed kilonewton per meter square. So first of all we will see the diagram. The AB is freely supported at A and B, and then 8 meters support length and uniformly distributed load of 15 kilonewton meter. So the 15 kilonewton meter UDL. So total 8 meters length span. Here a clockwise movement 160 kilonewton meter is applied to the beam at a point C. At point C applied here movement, that is 160 kilonewton meter with distance 3 meters. So the type of load is UDL, that is 15 kilonewton per meter. The movement at C 160 kilonewton meter clockwise, and the flexural rigidity A directly given 40 into 10 cube. For this beam need to calculate the slope and deflection. So he has asked only slope. So taking moments about A and equating the same, and calculate RB and RA. See here, RA plus RB is equal to what are the loads acting here. So here loads are, the RB is 80 kilonewtons calculated, and then here RA is 40. So 15 into, so UDL converted into point load. W is equal to W into L. So 15 into 8. 120. So the UDL load is, this one is kilonewton. So this UDL converted into point load. Now tell me what are the forces, upward forces and downward forces. RA plus RB is equal to 120 kilonewton. Now calculate RA and RB. So already here calculated. So taking moments about A. RB multiply with 8 is equal to 15 into 8 into half of the distance here. So W into L by 2. The moment is equal plus 160 kilonewton per additionally added at point C. So total moment is 1640 kilonewton meter is equal to the RB into 8 moment. So now calculate RB and RA. So we will get 80 and 40. Now what he has asked, what is the slope at point C? So taking A as origin and using Macaulay's method, the bending moment at any section X at a distance X from A. Similarly, already we have taken here. So take any section here with X distance. So the equation is EI d square y by dx square is equal to minus 40x plus 15x into x by 2. So 15 multiplied with x into x by 2. Already I told you W into L by 2. So that Wx into x by 2. So this term W into x into x by 2. Minus 160 to x minus 3 is equal to this equation finally after simplification 40x plus 15x square by 2 minus 160 into x minus. Now integrate this equation. So integrate, you will get EI into dy by dx is equal to minus 40 x square by 2. So integrate here. This term change into x square after integration 40 x square by 2. So 15 x cube by 3, that is 6 plus C1 constant. Clear? Now, so the bending moment at any section X at a distance with a small x from A minus 20x square. So after simplification 5 by 2. So after simplification we will get equation 1 minus 20 x square plus C1 plus 5x cube by 2 minus 160 into x cube. Sorry, x minus 3. So integrating the above equation once again. So this one is EI into d square y by EI into d square y by dx square. So now integrate. This is converted into, sorry, already integrated this one dy by dx. Now dy by dx converted into y, EI into y is equal to minus 20 x cube by 3 plus C1x plus C2. So again constant will come, that is C2. So why? Because we are doing double integration. Plus 5x to the power of 4 by 8 minus 160 into x minus 3 whole square by 2. We know that when x is equal to 0, y is equal to 0, so boundary conditions, therefore C2 is equal to 0. And when x is equal to 8, then y is equal to 0. So therefore, substitute here y is equal to 0 and find the C1 value. Similarly, C2 is 0. So substitute here x value 8 and then y is equal to 0. So in this equation, substitute those values, we will get the C1 value 356.7. Similarly, calculate C2. The C2 already calculated, that is 0. And substituting the value, so C1 is equal to 356.7 and C2 is 0. So now substitute those values in this equation. EI into Y divided by dx is equal to minus 20 x square plus 356.7 plus 5x cube by 2 minus 160 into x minus 3. So now for the slope at C, substituting x is equal to 3 meters in the above equation. So what is also slope at C point? What is the distance from C here? 3 meters. So what is the slope here? So you have to find slope at point C. So that here substituting x is equal to 3 meters in the above equation, up to C the 3 meters remains constant. We are neglecting the last term, so that EA into IC. So this slope at point C is equal to minus 20 into 3 square x is equal to 3, and calculate. You will get the slope at C is 0.0061 radians. So here like this, how to calculate by using this Macaulay's method, slope and deflection for a given beam. So here x is equal to 3 substituted in the equation 3 and neglecting the last term. So which term? 5 into 3 square by 2. So which is neglecting this neglected 160 into x minus 3. So C1 value calculated and C2 you know. So based depends upon these constants, depends upon the boundary conditions already calculated and substituted in this. So finally we got slope at C point. So the beam, the simply supported beam. So UDL is acting here. Suppose the beam is bent like this. So at this point at C, so why he has asked at C? At C point there is a moment and a clockwise moment. So that at C point there is A and B. So clockwise moment is there. So at this point, what is the slope? So the deflection. So deflection is YC and slope. So theta A, this one is theta C, or theta C or IC. So this is the slope at a particular point C. So like this you need to calculate the slope and deflection for a given beams by using Macaulay's method. So for this PPT I have taken references here as Ramamurtha, Strength of Materials, title of the book is, and publishers are Dhanapati Rai Publishing Company, and the R.K. Bansal title, and the title of the book is Strength of Materials, and the R.S. Kurmi and Gupta, Strength of Materials, title of the book, and Chand and Cope Publishers. So these are the references I have taken for this PPT. So take any one reference for other more clarification. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.